How you get around that, I don't know.
Yeah.
But it hasn't actually involved me particularly because my work was done mainly before the internet. I had to convince a lot of senior colleagues at the time what we were doing was correct, but we eventually did. I mean, there is a bit of work, a bit of publication on the net by people
who don't believe what we say, but actually there have been some publications by quite senior people who rather don't like my work because I won't go into mention any names here, but I think by and large our work has been accepted, and if you like to have bacteria in your stomach, well, you're welcome.
I guess part of your answer is to have good education. Because, I mean, if anyone at the internet can say, well, vaccines are dangerous and you shouldn't vaccinate your child, I mean, that has to do with education, that the people have read how vaccines work and what they actually have meant. And we know that in the United States now, some diseases that were always extinct are coming back quite heavily. So it is a problem, but I think we cannot forbid the internet and so on. So I mean, I say education, school education, university education is very important. Thank you.
talking about vaccinations. The article about vaccinations in the Lancet, which said related to autism, was just a pure course of action.
Yeah, that was later shown to be a real research fraud, actually, which has had a lot of impact.
But it's still being used as
I know. Okay, serious problem, please, up there.
Hi, good evening. I'm from Singapore. I'm Phyllis. I'm from June Rong Junior College. So I would like to ask for all of your opinions. Being expertise and specialized in what you do, how would you encourage more women to be scientists or even engineers? If not, why?
So good. So how would we have more women, I guess one young women going to science and particle physics? How many lady scientists do you have at CERN?
Yeah, we have a director general of CERN, which just came in, which is a lady, a very nice lady, very prove the fact that you can have the highest level position within one of the major physics institutions by being a person which had continued all her scientific life, and together with the fact that she's also belonged to she's also a woman. So I think that I don't think there is a problem there as far as we are concerned, as far as CERN is concerned.
I didn't want to attack CERN figure, but I mean, I guess many young women goes into PhD and do a PhD education, and maybe they do a postdoc. But many times they drop up, so there are many younger scientists are women, but full professors are not so many women. Is that the correct description?
Yes, but there are now more women in classes like in chemistry than men. It's like in terms of percent. So the start of the process, there are more women, and in my view, eventually, this will go to higher levels. So in our university, for example, there is special emphasis on trying to, of course, starting to increase the percent of women. There are a special fellowship and professorship. So I think it's the current situation is not so encouraging, but the direction is in a direction of having much more women in key positions in science. So in like 10 years, I think there will be equilibrium between the number of women and men in key positions.
I think even there have been more lady Nobel Prize winners in the last 5 years and so on. So maybe there are hope for the future. Please, on that side.
Hey, may I just ask Professor Rubia to speculate on the future of fundamental particle physics? So, for decades, physicists have enjoyed enormous success in wrapping up the standard model. To wrap it up, there was the Higgs discovery a few years ago. But it seems now fundamental physics is running into some kind of barrier on the experimental side. How can we probe, for example, quantum gravity? Are we going to have that any soon in the future, or if ever?
Future of particle physics. Is there a future?
There will be a future whether we like it or not. That's a fact. But anyway, coming to your question, it seems to me that, let me give you some other example of how science can evolve from one situation to another. If you look at the situation of the Watson and Crick who discovered the DNA, this was discovered by a group of in England, which was physicists doing physics, nuclear physics. And then suddenly they realized that the kind of ideas that nuclear physics had were perfectly correct and necessary in order to come up with this fantastic discovery, which is the discovery of DNA. And which was something different, but he was born in that kind of environment. So you should really separate the actual fact that everybody is doing this subject from the spirit which creates the atmosphere in which things can go and happen. And in the same way, in CERN, we have a large number of other possibilities of ideas which are not related to the making an even bigger accelerator, make more money, so we become more famous. The question is, you have to do something different. There are lots of things which are happening. I gave you the example of the web. For instance, an example, I can give you many other examples of subjects in which the fact that you have created a very strong environment in which a very large number of young people come and work together becomes a premise for whatever new form of science you will have to do. So you're telling me a new accelerator of the size of LHC, 30 kilometers circumference, how long will it take? Well, maybe it will be too long, it will not be the case. But there are other examples, which are, for instance, I will discuss this week, in which you're using muon cooling to produce similar situations, so forth and so on. So you don't know which is going to be the next idea. The next idea usually comes from a surprise. And I believe that science, all the fields of science, have to live on surprises in order to make progress. Because just repeating the same thing on a larger scale, and that's all, is not sufficient. For instance, we have in Uppsala a very interesting laboratory called the European Spallation Source. That is an interesting alternative to what is being done at CERN. I don't know whether the future, the smartest kid in town will go at CERN or will go at Uppsala, and so forth and so on. So I think you have to be prepared to have a more flexible situation next time.
Very good. That was correct, apart from it's not Uppsala, it's Lund, but your argument's still valid. So that shows, I don't think good ideas ever gonna stop, And if they're good ideas, they're gonna be new experiments, even in particle physics, not only biochemistry. Okay, more questions, let me see. We have one who gently sits here in the middle, so please, Mike.
Good evening. My name is Max Colla. I'm a lecturer in physics at SUD. I would like to ask a question to Professor Rubia. I'm a fellow Italian as well.
Molto bene.
My question is relative to energy production. In fact, we've been talking about it. There have been many attempts to nuclear fusion. All failed and still not developing at the rate we would like them to develop. So ITER has been delayed for several years, it appears now, possibly because of the lack of money or otherwise. And I would like to have Professor Rubia's opinion on what is the problem there. Is it technical still, or is it actually political will or lack of political will?
Technology or politics? What is the worst?
There is one statement which is always made, which is totally correct. The one which says the fusion is the reactions which is used for the sun to produce energy. The energy coming from the sun is produced by a weak process. is produced by a process, is aneutronic, no neutrons, and a weak process. So therefore something which is very slow to happen. The lifetime from burning the sun is something like 6 billion years. And this is done with a speed of producing energy, which is a density of energy equal to the energy density of a human body. Both the human body and a piece of the center of the sun produce the same number of watts per second or per kilogram. So it's a very slow process. The process which is proposed for fusion that you're mentioning, on the contrary, is a fast process. It's produced is not aneutronic, because it's producing tritium, and tritium is producing 14 MeV neutrons. In fact, the fusion is producing 7 times more neutrons and high energy neutrons than fission. And therefore, if you want to develop this system, you're going, so to speak, in a different direction. I am not convinced myself that we are doing a good job in advancing. Of course, everything is fine, everything can be done, but I don't expect great surprises coming up from fusion in this respect. Probably the fusion, probably the pizza produced with the fusion will be the most expensive pizza in a long time. But anyway, coming back to the point, it seems to me that in my view, one should concentrate more on fundamental physics, because fusion can be aneutronic. While fission, you're obliged to have neutrons in there, and you have long-lived elements, you have radioactive materials, this and the other. There are several other fusion reactions, because there's many fusion reactions as chemical reactions, there are millions of them. In particular, there is a reaction of proton on boron. Boron 11 plus proton gives you 3 alpha particles. That is something which has no gamma, no beta, 3 alphas which produce directly energy, and is totally aneutronic, is totally available. I believe that in a few hundred years from now, when people will finally get fusion on the road, that there will be probably the aneutronic fusion will be the winner, because this is an extra step that you don't get from fission. Many of the things you're doing with fission, you're also doing with fusion, and fission has all the problems you know, and many of the problems of the fusion will also be problem of the fusion. No question about it. Of course, this means it has to be developed, to be understood in the same way you develop nuclear power. But the idea that the nuclear energy could become the primary form of energy in the future to come, it's my opinion rather remote. And I believe, for instance, we'll discuss tomorrow, that things like producing clathrates, or producing shale gas, or producing natural gas, methane, are, in my view, enough in number, enough in solution to solve the energy problem in a successful way, at least for the next 1,000 years or so. So we have plenty of time to worry about fusions. If fusion will be there, in my view, will be a different fusion, because it will be an aneutronic fusion. Because that is something which eliminates all the problems which are there with fission, while the present day fusion, it makes them worse than it makes them better.
Thank you. I think now we're coming closer later and later. So there is now one more question. And the guy in the red shirt is good, well positioned. But this is the last question. It's to be a clever one. Shoot.
Hello. I'm an undergraduate in NTU.
I'm sure it's going to be clever.
I'm going to ask a little personal question. Can you share with us, when did you realize that what you want to do for your life is to pursue research?
Yeah.
Like, is this something that you know you will do when you were little, or you come to some realization later in life, some accidents, or are you still unsure?
Ari, when did you see the light?
I have a similar question. Who inspired them?
In my case, I just chose chemistry because my friend told me that I have good eyesight. So in the beginning, I did not have any idea. I just want to do the best that I can. And it comes with time. So some people probably talk with their friend and choose the right direction, like now study of the brain. In my case, the longer I work, the more it seems that this is what I want to do.
Oh.
So it's not that I woke up one day and decide that I'm going to use computers to model biology.
Good. Warren, when did you see the light? In Adelaide you were, right?
Well, I came from Adelaide,
Yeah.
yes. When did I decide to be a research worker? People ask me that. I never did decide to be a research worker. I wanted to be a doctor, and that's what I did.
Yeah.
And I worked as a pathologist,
Yeah.
a clinical pathologist. And when they told me I'd won the Nobel Prize, they also told me that I was the first person since, the early 1970s or something like that, who actually was a clinician, not a research worker, who won the Nobel Prize.
All right.
Okay? So my research work was done as part of my normal day-to-day work as a doctor.
Yeah. Robia, you...
Doctors keep their eyes open.
Yeah, very good. So Robia, you said you were reading a lot from your father's books or something like that.
Oh, you told these kind of things. Fine, I can explain a few things at this time. First of all, there are two aspects. One is to discover that the science is essential. It means curiosity is essential. You are driven by curiosity when you're a young man. And this happens very early. And young children are always the one which has the highest level of curiosity. Even Albert Einstein, after 30 years, did not invent anything anymore. So it was developed tremendous things, but these ideas were already ideas that he started at the beginning. So to get into science, to get into development, it's an early phenomenon. It goes with your early age. Then when you get older, you develop more accurate the technology, but fundamentally the basic choice already been taken at the beginning. And at that time, I was in Italy just after the war, very difficult times, very few problems. The war has been an incredible event to all of us. I think 84 million people died during the Second World War. And many of those were in Europe and so forth and so on. It was very, very difficult. And in these conditions, I remember that my father wanted me to become an engineer because he wanted me to do something practical. And science at the time was considered like poetry. You know, at those times, a person, a well-behaved family, will not have a scientist as a husband, rather an engineer, a lawyer, or something else, or practical activities, while science was considered like poetry. It's not like today. Today now we had scientific revolution. Everybody thinks of science is with a capital S. At that time was considered to be something very, very secondary. But I wanted to do that, so I went to Pisa. Pisa had a very nice scuola normale, on which Fermi was also there, Segre went there, so it was a well-known history. And I go there, I apply, and I got there were 10 positions, and I got the 11th position. So I came back home, completely convinced that now time was for me to stop to dream about science and so forth, and go to do something practical, like becoming an engineer to build something which I could sell and make and so forth and so on in a normal system. And 3 months after I was there, one of the person which I never met, I don't know who he was, decided that he was giving up to become a scientist. So I came through as a 10th person with some delay, and I started respectfully my lifetime as a scientist, avoiding the ideas that my family and my conditions were, so to speak, making important to us. So the message is very clear: try to do what you really want to do, independently whether it is of interest to the others and whether it is valuable to you, because I mean there are things which you have to be convinced of, which are impossible to, so to speak, to avoid. And certainly becoming a scientist is one of the activities of this type. Many others are valid, but science is certainly one of them.
Great, thank you. I think this was actually a good last question. And I also think the statement of Professor Rubia did, that science is like poetry. I think that's a good statement when we're here now in our art school. Thank you very much.
Thank you, Professor. Now, ladies and gentlemen, wasn't that an intriguing session? Thank you for your active participation. And before we come to the end of the event, we would like to invite Professor Anderson to present a token of appreciation to our guest panelists. Professor Anderson, please. First, we would like to present the token of appreciation to Professor Rubio.
Thank you very much.
Next, we would like to present a token of appreciation to Professor Warren. And last but not least, Professor Washoe.
Okay, one more applause for our...
Thank you, Professor. We would now like...
Now we have one applause for the audience, right?
Thank you, Professors. We would now like to invite Professor Ling San and Professor Hua on stage for a group photo with Professor Anderson and our panelists.
No, we